Okay, so some things you should already know about electric charge. The first thing is that there are two types of charge, positive and negative. This came from Benjamin Franklin, who was quite the scientist as well as a statesman, and Franklin picked one to be positive and picked the other to be negative. It turns out that it probably would have made a little more sense had he gone the other way, but given that the electron was not discovered until centuries after his death, you can kind of forgive him the lapse. Next, those charges, positive and negative, opposite charges attract, and like charges will repel, right? You should already know that. Good. The third thing you should know is that protons are positive and electrons are negative. Most electricity comes from the movement of electrons while the protons stay still. Protons are bound in the nuclei of the metals and conductors and whatever else, and so it's the electrons that do the moving. There are exceptions when you'll have entire ions or even ionic molecules moving, but those are rare and we're going to ignore them. So electrons move, protons stay put. Finally, things that conduct electricity well are called conductors, and things that don't conduct electricity well are called insulators. Those are the four things that you should definitely already know. The rest of this you should know, but maybe it's been a while and you need a refresher. The reason why metals are good conductors is because they have free electrons. So electrons being free to move around from through the shared valence shell of a metal is what makes metals metallic. It's what makes them malleable and ductile and all that. It's what makes them good conductors. In insulators, the electrons are bound in place. In a semiconductor, you can have electrons that are bound in place most of the time, but under certain circumstances can jump up to a shared valence shell and thus behave like a metal. On that note, pure water is actually a really bad conductor. It's a covalent molecule, the electrons are bound to the atoms, so it's really a good insulator. But if you get into a pool of perfectly pure water, the salt from your skin and things like that are going to very quickly diffuse through the water and turn it into a really good conductor. So pure water is a poor conductor, but water that pure is so rare that get out of the pond when there's a lightning storm, okay? The final thing that you should already know is that there are three ways to charge things. The first one is contact. If you take something that is charged and you bring it over and you touch it to something that is not charged, well, you have yourself a flow of charge. From the charged thing to the non-charged thing, this one becomes a little less charged, this one becomes more charged. That's charging by contact. The next one is charging by friction, which you've done if you've ever worn socks and shuffled your feet on a rug and then touched your friends to shock them, right? So you charge yourself up by literally scraping electrons off of one surface onto another. This is also what causes lightning, charging by contact as clouds move over air that is moving less, most likely, right? So you have a cloud moving over an air layer. The air layer below isn't necessarily stationary, but it's moving slower than the cloud layer above it, and electrons can literally scrape off from the air to the cloud or vice versa. The third way to charge something is via induction. This can be temporary and you can polarize things. If you take a rod and you bring it near an insulated metal sphere, you take a charged rod, you bring it near, it'll polarize that sphere. The electrons will either be attracted to the rod if it's positive or repelled from the rod if it's negative, and the protons will be left behind. You can then ground that side of the sphere and exchange some electrons with the Earth and therefore bleed off some of the charge. You then remove the ground, remove the rod away, and you end up with the ground slightly more charged, but that probably doesn't matter. The sphere will have a definite charge on it. The reason why the ground being charged won't matter necessarily is because the Earth is so huge and it's got so much charge, positive and negative, in it that any charge that we are able to put into the Earth is going to spread out over the whole planet, and any excess charge that the Earth might have is A, probably very temporary, and B, so spread out that it basically doesn't matter. So there you have it. Those are the things that you should know, the basics about electricity. In our next video, we're going to talk about what exactly charge is.